series, this time all about watertight concrete. Are you specifying pipe B waterproofing correctly? I'm your host, Andy Ferguson, and today I am pleased to welcome back PCE board member and MD of CSSW London, Ben Hickman. Good morning, Ben.
Morning, Andy. How are you?
Not bad. Yourself, good sir?
Yeah, I'm doing well, thank you. Feeling a little bit sorry for myself with a cold, but yeah, doing good.
Oh, I hope you're not trying to give away all these COVID gems into our audience via a virtual means.
I am not. In fact, I went for a COVID test yesterday morning and got the results today, and I'm COVID clean. But yeah, just got a little runny nose and a slight cough and stuff. But yeah, doing good.
Cool. Well, for all those that have been tuning into our webinars on a regular basis, as always, a big hello to you. If you're one of our new listeners, then a big welcome to you. And I hope you get a lot of value learning from today and you enjoyed the chat. In addition, I just want to make a special mention to the international audience that's out there. I think we've got people tuned in from Europe, the Americas, Australasia, principally Australia, actually. I just want to say a big thanks for tuning in at whatever daft o'clock time that it might be over there. And if you are one of our international listeners, then please do come and say hello via the chat. Now, just for all those that over the course of the webinar, you have any questions you want to pose, I just want to give you just some quick pointers on how you can pose those questions. First things first. You can principally use the chat functionality. Now, if you are on a desktop, the chat functionality, depending on your settings, will either be just to the left or the right of you. There, just hit the chat functionality. There's a wee box there that says type your comment and feel free just to kind of rattle away and say a wee hello, good morning to us, or type your question. Similar for mobile devices, if you literally just pull your screen up just a little bit, you will see that comments functionality in there. Again, feel free just to say a good morning, hello. I can see there's people in there that are saying good morning already. Good morning to all that I've just typed into the chat functionality. But there is other ways in which you can pose your questions over the course of the webinar. You can email them direct to me over the course of the webinar, and it's simply andy@property-care.org, andy@property-care.org. Or alternatively, if you are so socially savvy, you can go via any of our social media channels and pose it that way, either through Twitter, LinkedIn, or Facebook. Just simply look for a tag, just use the native search on those platforms, and you should be able to find us. I just want to say a wee note in case anyone has any problems over the course of the webinar. I do realise at 9 o'clock, everyone's switching on their PCs. There can be quite a pull on demand on the internet. If you do have any issues whatsoever, there should be a reconnect functionality that pops up on your screen. Simply hit that. For any of our audience that see any kind of comments on there that I missed, if you can just point anyone to that there's a reconnect button on there, and you should be able to reconnect, not a problem. Now, just before I kind of just quickly jump on the bench, I just want to throw this out to the audience. I have a question for you. We are in the process of kind of thinking about what sort of webinars we want to really kind of plan for, and I'm keen to hear your voice. I mean, we have ideas and suggestions, but are the ideas and suggestions that you guys want? We are keen to hear from you. I mean, we've got things such as, should we be doing webinars on the new Green Homes Grant Scheme? Should we be doing it on invasive weeds and the emerging changes to the guidance? Should we be doing things such as ensuring buildings are dry? Tell us what you think. I am keen to hear. We are keen to hear at the PCA from yourself and what we can actually provide you. So just get those fingers going. Tell us what you think in the comment section. I would love to hear. Ben, we've got about a minute or two left. I just want to say it's great to have you back. I mean, for all our listeners that are a little bit unaware, Ben headed up our very first webinar back in February under the title Avoiding Failures in Podium Deck Waterproofing. Ben, we've only got like literally a minute, but I mean, how's life been treating you since then, back in February?
Yeah, good, thank you, Andy. And thank you for all the webinars that you've hosted and all the techie stuff you've done since then. You've done a good job. But yeah, life's treating me well. Thank you. Yeah, despite all the COVID stuff, business is good, and yeah, life is generally pretty good for us. Thank you.
No, well, that is great to hear. I mean, the last time you gave us some gossip, some really good, juicy gossip in the world of waterproofing. Are you going to let us into anything now? Is there anything hot off the press at the moment in time? Are you going to keep that under your chest?
I don't know if I know any gossip. Yeah, we're doing some guidance on blue roof waterproofing. Well, it's on delivery of blue roofs. It's a Syria guidance document. So that's what I'm thinking about quite a lot, and that's going out to the project steering group. It is out with them right now, so that's the biggest thing for me right now. But no other gossip, I'm afraid.
Oh, well, that's okay. Well, guys, we're just about to, just for everyone that's joining us, a big good morning to you. We are literally just about to start. Big welcome to our feature presentation today, Watertight Concrete. I'm your host, Andy Ferguson, and beside me, I have MD of CSSW London and also PCA board member, Ben Hickman. I suppose it is bang on 9 o'clock at the moment. I suppose, Ben, Watertight Concrete. I have to tip my hat over to for raising the question. Are basement waterproofing designers correctly specifying watertight concrete, or type B, I should say? And what can we do to really protect our reputation and also waterproofing design? Now, I know a lot of your peers are on the call today, so no pressure on yourself, good sir, but I suppose over to yourself and our feature presentation today.
Brilliant. All right. Well, thank you all for joining us, and welcome to my little office in Bedford. So I'll be talking for the next 45-ish minutes, and then we'll have some time for questions. But this is the agenda for the day. We're running through a sort of an intro to who I am and some of the kind of the mindset that I come with. We'll talk about concrete. We're talking about sustainability, probably a lot more than you were expecting, and I'll explain why. And then we'll talk about British Standard 8102, which is the code of practice for protection of below ground buildings against water from the ground. We'll go on to talk about BSEN 1992, which is Eurocode 2, which parts of that. We'll talk about crack widths, waterproofing additives, and I guess just as a waterproofing designer, how do I approach designing watertight concrete? And then we will do 3 case studies towards the end. So thank you for joining me. So my name's Ben Hickman. I run CSSW London. Most of what I do is expert witness work, dispute resolution, defect diagnosis, that sort of thing. I need to say that I'm not a material scientist. I do have a degree in material science, but I wouldn't claim to be a materials expert. I'm also not a structural engineer, so I can't do any crack width calculations, rebar design, any of that stuff. That's not what I bring to the table. What I bring to the table is a waterproofing mindset. So I just need to put that caveat out there. And let's crack on. I thought we'd start, and Andy will help me here, with a quick poll just to get some engagement from you guys. Is well-compacted concrete watertight? I thought that would be an interesting place to start. So, Andy, can you run that poll for me? I don't know how that works.
Yeah, well, folks, that poll has now been pushed out to you. Now, if you're on a desktop, it should just naturally pop up for you. If you are on a mobile device, you just need to kind of pull it up just a little bit, and you will see it's there. I can see we're starting to get responses. I'm not going to take the result and say what those responses are and the percentages just right now. We're just going to leave it open for maybe about another 6-7 seconds or so. So guys, if you're going to vote, now is the time. It's looking interesting, Ben, I'll have to say, the results. So guys, 5, 4, 3, 2, 1. Well, I'm just going to end the poll there. Now, Ben, just in case you can't see the result, folks, you should, hopefully everyone else should see the result, but answers to yes, 12%, answers to no, 43%. Now, it depends the largest at 44%.
Very good. Yeah, excellent. I think, yeah, it does depend. It's not necessarily straightforward. Probably worth referencing here, British Standard 8102, paragraph 9.2.1.1, note 1, which says something along the lines of, well-compacted concrete has good resistance to the transmission of water. So I would take that to mean that it sort of would reduce the level of water ingress, but I wouldn't expect normal, well-compacted concrete to be watertight. So thanks for your engagement. I thought I'd also share this, which is a poll that I ran on LinkedIn a few weeks ago, just to sort of gauge interest on this seminar and talk about, you know, where are different people at, what are the questions that people have. It had about 203 votes, which I was very surprised by, and generated some good conversation on LinkedIn. So, yeah, what crack width is required for watertight concrete, and I think it was interesting. Oh goodness, sorry, I'm trying to get a pen up, which I have now done. So, what crack width is required for watertight concrete? Is it 0.2 millimeters? Is it 0.3 millimeters? Is it other? I think it's just helpful to show these results as we go through the rest of this talk. So 0.2 millimeters was the most popular, and other was the second most popular. Just bear that in mind as we go through. So I thought we'd talk a little bit about history. I saw Paul Green put a comment on there about William the Concreter. I don't know if that's true at all, but first use of concrete was apparently in 600 BC-ish. And I was fascinated to know the earliest use of reinforced concrete for a multi-story building was in Swansea, of all places, in 1898. Concrete remains the most used construction material in the world. You could argue it was timber, but it would be the same by volume, but obviously concrete weighs more. So concrete is the most used construction material in the whole world, and sustainability is now a critical issue. And I'm going to try and explain why I think that in a moment. What is concrete? Well, in some ways, very simple. You've got some stone and some sand and some cement. We would typically call stone an aggregate, but actually, the more you drill down into the detail, the more complicated it becomes. So really, this section should include some rebar, because reinforced concrete would include a reinforcing, which is typically rebar. That's steel rods. But in addition to your stone, your sand, your steel, and your cement, you have voids and you have water. And because it's a composite material, different elements behave differently. So if there's a lot of stone in one section, that obviously behaves differently. If you have different stone, that could behave differently. You have different binders that could not be cement in some circumstances. So actually, although it's the most widely used construction material in the world, and there's been masses of research into concrete, there is still an enormous complexity to it. And the more I've looked into concrete, the more questions I've had. And time is a relevant factor as well. So there's various reactions that go on, and some of those are chain reactions as cement paste forms crystals and solidifies. So there's a lot going on in concrete. But going back to the sustainability, and I'm going to be just going back to sustainability a few times throughout this webinar. Concrete or cement production, if it were a country, would be the world's third largest emitter of CO2. And that is phenomenal. That is evidently cement production is a huge contributor to our global carbon dioxide emissions. And the reason for that is partly explained by, well, how is cement made? So cement is made by you chucking some raw materials, and out comes something called clinker. Clinker is ground up, and that makes cement. But the way that happens is you get hot air at 1400 degrees C, goes through here, and the chemical reaction emits part of the chemical reaction. The outcome of this chemical reaction is carbon dioxide. So not only are you heating a huge amount of material to 1400 degrees, which is going to use a lot of energy, and there's going to be some serious carbon emissions there, you also have the chemical reaction itself releases carbon dioxide. So cement production leads to significant carbon emissions. And you might say, well, Ben, I'm not a tree hugger, I don't care. Well, I'm also not known for my tree hugging desires. I'm certainly not vegan. I love my red meat. But it's very relevant for all of us because of professional ethics. And this is a fairly new thing. I think it happened in about a year ago. I think that's right, where all of the professional bodies involved in construction, so that includes Riba, ICE, CAB, CIOB, all of the CIBC, all the significant professional bodies came together and said, actually, this global warming crisis, this climate change crisis is serious, and we're not going to wait for somebody else to say you need to consider climate change. We as professionals we're going to own that ourselves. And so by way of example, I've taken the ICE, Code of Professional Conduct, so that's the Institute of Civil Engineers. And for those of you who don't know, Code of Professional Conduct would typically say things like, don't commit fraud. And actually, if you breach your Code of Professional Conduct, you could be struck off from being a chartered civil engineer, for example. So it's in that sort of body of this is how we must behave. And Rule 4 of the ICE Code of Professional Conduct now says members shall have due regard for the environment. It goes on to say that that we should have an appropriate audit trail. Sorry, that's a little bit underlined unpleasantly, but an appropriate audit trail to show that we've taken reasonable steps to consider our impact on the environment. And I've put here this picture of this is a second-story basement. You can see all the steel reinforcing there. It's a 2-meter thick slab. Were the professionals involved there seriously considering the impact on the environment? Could we have used less material? And if the answer is actually we could have used less material, but we just didn't care, that's a breach of professional ethics, and that's a serious thing. Now, why does that matter? Well, we'll go on to talk about thickness of section is very relevant as we talk about watertight concrete. So that's why I'm talking about this sustainability things, because we need to seriously consider our use of materials, and in consideration of hydraulic gradient, which we'll talk about in a moment, how thick that concrete section is important for waterproofing. So if we can have thinner concrete sections, we can have less impact on the environment, and that's why this is very relevant. So concrete, sustainable use of resources. Well, why does that matter? Globally, since about 1950, the emissions of CO2 have been increasing extremely high. So that's an exponential curve. And back in 5 years ago now, the Paris Agreement was 5 years ago. And that's when the world came together and said, guys, we can't let global average temperatures increase above 1.5 degrees. And so in order to reduce our global average temperature rise, we need to reduce our emissions. And this is the sort of the steepness of the curve that we need to reduce the emissions by. And that requires an 8% year-on-year reduction in our use of, in our emissions of carbon. So if we're using 8% less concrete this year than last year, that would be a good thing. Generally speaking, we're not, though. So enough about sustainability for a moment, and back onto waterproofing. So British Standard 8102, Code of Practice for Protection of Below Ground Buildings Against Water from the Ground, starts with this sort of design flow chart where we say you need a design team, you need a desktop study, you need to know what the water table is doing, all that sort of stuff. And then you go on to say, well, what are our structural requirements? And then you select how we achieve in the waterproofing. And you could go with type A, type B, or type C, or a combination thereof. And today we're talking about type B. I wanted to show this. Bear with me a second. Oh, didn't want to do that. I want to show this, which is table 1, and highlight this. So if we're going for watertight concrete, which is type B, structurally integral protection, we're in the realms of this, which is shown here. But it's interesting to note that BSEN 1992 is mentioned here and here and here, and that's the Eurocode 2. The text regarding structurally integral protection, which is type B waterproofing, is in chapter 9 of BS 8102, and I wanted to highlight this. So, structures providing type B protection should be constructed of reinforced concrete or steel, so steel would be BSEN 1993, and designed according to the relevant part of BSEN 1992, which is Eurocode 2. But which is the relevant part? It's a very interesting question. And if you wanted to, you could trot off to the British Standard Institute website and go to their shop and spend about £1,000, actually quite a lot more than that, to get all of the relevant components of the Eurocode 2. There's actually more than that. There's -4 and some others. But the point is, I think, clear. So which is the relevant part of Eurocode 2? So you've got general rules for building. That's part 1. So if you're 2 stories up, you're still wanting to comply with your general rules for building. It's structural. You don't want the building to fall over. That's the stuff going on there. Fire design, I think, is self-explanatory, but not particularly relevant for basements in terms of how you're achieving watertight concrete. You don't need to think very much about fire design normally. Concrete for bridges, well, no, a basement's not normally a bridge. So the relevant part is this: liquid retaining and containing structures, which is BSEN 1992-3, which I'll try and talk about as Eurocode 2-3 from now on, I think. I come across some people who say, well, that's liquid retaining and containing structures. Basements aren't liquid retaining or containing. And I would argue that, well, actually, a basement is a liquid retaining structure, in the same way that we'd happily call an earth retaining wall earth retaining. You're trying to retain the earth from coming in the same way you're trying to retain the water from coming in. So I would say that the relevant part of BSEN 1992 is -3. So just going back to this, BS 8102 says design it to the relevant part of Eurocode 2. I would say the relevant part is Eurocode 2-3. So this image here is of a podium deck. So it's a structural element, and it was designed to Eurocode 2 Part 1. And you can see that there's some cracks. So that's perfectly acceptable structurally. It's not supposed to be watertight concrete. This was during construction. That podium deck hadn't yet received the waterproofing over the top of it, which was to be a hot melt. It had some cracks and it had some water ingress. Structurally, that's no problem. And it's not supposed to be watertight, so it's not a problem. It's designed to Eurocode 2 Part 1. But this is the second story basement, and all of this water is from construction. It's all, it's an open building, so there's nothing odd there. This is a first floor basement floor slab, I think, and there's some water ingress through there. Structurally, it's fine. You would expect it to have some cracking, and that's okay. This wall here is of watertight concrete designed to Eurocode 2 Part 3. And if we had cracking and ingress through that would be of significance, and it would be a problem. So these walls are designed to Eurocode 2 Part 3, and they should not leak. This ceiling is designed to Eurocode 2 Part 1, and it should leak. I wanted to highlight this document, and I'll be using it for a lot of the webinar. It's called Concrete for Basements, published by the Mineral Products Association, written by Narayanan and Goodchild. Very helpful, useful document. It's a little bit old now and probably could do with an update due to a new Syria guidance document. But this is a very good, helpful point. Eurocode 2 is, from my perspective, pretty dense, pretty hard going. And this Concrete for Basements document is easier to make sense of, and it does apply specifically to basements. So if you would say, okay, my British Standard 8102 says to look to the relevant part of the Eurocode. The relevant part of the Eurocode is 2 Part 3. The next thing you would be looking at is what tightness class do you need? So if you're designing watertight concrete, how watertight do you need that concrete to be? And that would be tightness classes here, which actually seem very similar, in my opinion, to BS 8102, your grades of waterproofing performance. So here you've got tightness class 3, no leakages permitted. In BS 8102, you've got grade 3, where no leakage is permitted. Somewhere up here, you've got a degree of leakage is acceptable. BS 8102 would talk about grade 1 waterproofing performance, where some leakage is acceptable. It gets a little bit more complicated here between 1 and 2, but it's probably worth pointing out that tightness class 2 says that cracks through the section should be avoided. Now, that's just not practical for basements. It's unless you're using post-tensioning or something like that, you will get some cracking through the section. And so you wouldn't normally say, okay, I want basement waterproof concrete to tightness class 2. That you're not going to meet that requirement, to the best of my knowledge. So what you're talking about when you say I want watertight concrete, according to Eurocode 2 Part 3, is tightness class 1, where actually some surface staining and damp patches are acceptable. And that really, to my mind, is the same as grade 2 waterproofing performance in BS 8102. So as we go on to talk about watertight concrete and what crack width is permitted, the maximum crack width that can be permitted, what we're talking about there is tightness class 1. So after saying, okay, I want watertight concrete to tightness class 1, what next? Where do we go from there? Well, the next point in the sort of design flowchart is you need to decide what your hydraulic gradient is. And your hydraulic gradient sounds complicated, but it's very simple. It's what is your hydraulic head? So what depth of water are we considering? And what is the section thickness? How thick is that wall, flat, or floor slab? So here's a little example. This is a double-story basement, which we'll look at during the case studies. And ground level is up here somewhere. And I said, well, we could have water up there at some point. So your maximum hydraulic head is 6.3 meters. The smallest, the thinnest concrete section here is 0.19 meters, so 190 millimeters, fairly thin. The developer needed their car parking spaces. So your hydraulic gradient there is 6.3 meters divided by 0.19 meters, which gives you a hydraulic gradient of, I think, 33. You can then punch that into this table, which is again is from Concrete for Basements, or you could go to the Eurocode, but 33 is somewhere there, and that gives you a maximum permissible crack width of 0.06 something. So just remember, I showed you that LinkedIn poll where the options were 0.2 millimeters, 0.3 millimeters, or other. Well, 0.06 millimeters fits squarely into the other category and is very difficult to achieve, really. That's a very tight crack width. And that's hydraulic gradient. So if you go to Eurocode 2 Part 3, you say, okay, tightness class 1, then you look at your hydraulic gradient. What's the biggest crack you can have? In this case, it's 0.06. This is the 0.2 millimeters, which is the biggest crack width that you can get away with in an ideal circumstance, but that is quite unusual. So what determines your crack width? Well, I've already said I'm not a structural engineer. I don't design rebar and I wouldn't do crack width calculations, but my understanding is your crack width is affected by many different things, including what is your rebar, where is it, what's your cement binder, what is your pore size, where is your pore? So that would be affected by your edge restraint or your end restraint. All of that's going on. So when I say to a structural engineer, oh, please can you do some crack width calculations? They don't like it. Because there's a lot of work involved and there's a lot of it. Well, which bit? Because the crack width's different for different pores and different parts of the building. So you've got to use a lot of professional judgment and figure out, well, okay, worst case scenario, this bit, and how does that perform? But corners are typically the worst. Thicker sections are typically perform worse than thinner sections. There's a lot going on and it's complicated. Life is made a little bit more easy by Series C766, which is a fairly new document. And that would encourage us to use granulated blast furnace slag, which is it can be an alternative to cement, and in theory, at least, it's more sustainable. But the reason why that's beneficial for your crack widths is it's a slower reaction and it's less exothermic. So your early age shrinkage cracking is not as bad. Helpful document for structural engineers who are looking at crack width. But what about additives? We haven't mentioned additives at all. What about waterproofing additives? Well, Eurocode 2 Part 3 completely ignores any additives. It simply talks about getting your crack width down low enough. And there's a school of thought amongst structural engineers that I speak to that really just don't buy. They don't think that waterproofing additives do anything. They think it's snake oil. And that's not helped by just about any waterproofing additive you get. You go to the BBA or equivalent and you'd read through that. And the BBA says, oh, when you're using this system, design it to Eurocode 2 Part 3, which ignores the additive. So you get the circular argument where, well, what's the benefit of the additive? Because I need to get my crack width so far down anyway. Also, additives tend to take time. Sometimes they only work in the presence of water. The data that's available isn't great. Often there's commercial interest, so people don't want to say what the additive is. So there's a lot of skepticism in the industry saying, well, I don't want to use additives because I think it's snake oil. There is that element going on. My own opinion is there's a lot of value in using a waterproofing additive, and actually there's a lot of literature out there that does help. I've given a little screenshot there, but that's that, which is a literature review that I did a couple of years ago, and it was published in Construction Materials Journal. But a literature review is simply looking at what have other people said in the academic literature. I haven't done any research myself. I simply looked at what is the research that's available there. And there is this thing where the data isn't actually very good. Some of the research that's done on waterproofing additives isn't very helpful because it doesn't allow for the binder change. I won't go into that, but generally speaking, I would support the use of a waterproofing additive, and I think there is good academic literature, particularly for crystallizing waterproofing additives. But in addition to that, even if it wasn't doing anything, using a waterproofing additive gives us some sort of quality assurance normally, and it also gives a warranty. And so if there is some seepage, commercially you have some sort of recourse to get some resin injection done or something like that. So Eurocode 2 Part 3 is talking all about getting your crack width small enough for autogenous crack healing to be effective. Now, all concrete would have some degree of autogenous crack healing, which is simply the leftover cement reacting with water, and that causes more cement paste. So if you have a small crack and you have a bit of water, then cement paste would typically fill that crack, and that's what autogenous crack healing is. But if you have a crystallizing waterproofing additive, that would enhance your autogenous crack healing. And so my view is, well, if the Eurocode says get your crack widths down this low, but you use an additive, you might expect a slightly bigger crack to still crack heal. And this here is a nice graphic from a guy called Tanvir, who's now in Canada. And you've got some cracks of 0.5 millimeters very clearly being filled up with these white crystals, which are magnesium oxide, which is not a commercially viable waterproofing additive, but helpful to see. So just going back to the sustainability thing then, if the Eurocode is saying thin sections need much tighter crack widths, then you might want to use a thicker section. Or if you're going with the thin section to get your crack widths down, you end up using a heck of a lot of reinforcement. So if the Eurocode leads to higher embodied carbon in your construction, would the responsible professional be saying, well, in the interest of sustainability, we need to at least consider using a waterproofing additive? So there's some things to think about there. To get your crack widths down, you might also use a granulated blast furnace slag, so that would be a more sustainable approach, typically, depending on where that's coming from. you'd also want to use less rebar and less concrete, particularly with a basement floor slab. If you can get your thickness down, then the amount that you need to excavate out of your building site reduces. So the embodied carbon in digging the hole is reduced. The embodied carbon in your use of raw materials up here is reduced. And that is a responsible thing to be doing. And as a professional, we need to be looking at that. There are additional things that you can do in terms of the shape that you form your concrete out of can perform mechanically better, but I won't go into that really. So, should you use a waterproofing additive? Well, we've already covered, we've already looked at this where I highlighted that, the relevant part of BSEN 1992. But interestingly, it immediately states concrete structures containing a waterproofing admixture should be considered as having a lower degree of water transmission. So you could say, well, here's type B structural waterproofing, look at the Eurocode 2 Part 3 and use a waterproofing additive, which you would consider having a lower transmission rate. I've already referenced this, but you get this little bit of a feedback loop because you say, okay, I'm using a waterproofing additive. Well, British Standard says I should get a UCAS accredited body to certify that this is a good system. So the most well-known would be your BBAs. But your BBA certificate does this in, what is it, general, paragraph 19.1. So you start off and you look at, okay, I'll start with BS 8102 because it's a basement. And that says, okay, if you're going for type B, use the Eurocode Part 2. Sorry, Eurocode 2 Part 3. So you've gone from 8102 to Eurocode 2 Part 3. But then 8102 says you can use an additive. So then you use an additive, but the additive refers you back to the Eurocode 2 Part 3. And so for a structural engineer who's skeptical about whether an admixture actually does anything, you get a loop where you're saying, well, okay, I've got to design it to Eurocode. I want to relax that because I'm using an additive. But the BBA certificate says design it to the Eurocode. And that's a little bit of a sort of a feedback loop that is unhelpful. So I posted this on LinkedIn the other day, just trying to explain all that's going on when you're thinking about designing watertight concrete. And so you start here and you're saying, okay, I want watertight concrete. And you say, okay, well, that's in BS 8102, and it's type B watertight concrete. I'm typically wearing this hat as a waterproofing designer. And so 8102 tells you to go to the relevant Eurocode 2 Part 3. And that says figure out your hydraulic gradient. So then you've got to know from the ground assessment what is the hydraulic head. And then you're looking at section thickness and bore size and all that kind of stuff, trying to get your crack widths down. And Syria C766 is helpful to you on that. But the whole time, I'm always thinking about this, my professional risk mitigation. So we just renewed our professional indemnity insurance policy. So it's £10 million professional indemnity, and it costs a fortune. And I don't want anybody to claim on my professional indemnity insurance, so I don't want a leaky basement wall. And that's the sort of mindset that structural engineers and professionals typically think about. I don't want any design failure to be on me. But when we think about professional risk mitigation, we must be mindful of this, our professional code of conduct. So normally you don't really think about it. I'm not fraudulent, so I don't need to think about it very much. But your professional code of conduct demands that you start thinking about sustainability. And your sustainability might say, well, use less rebar, use a different binder type, use a different section thickness. And maybe you should be using a waterproofing additive to mitigate not quite reaching your very small crack widths in Eurocode 2 Part 3. All of that's going on. And my big plea to you listeners today is to record your thinking, your rationale. So if you just haven't thought about it, then you might have been negligent. But if you do these sort of touchstones where I've referenced BS 8102 and I've followed the design flowchart and I've referenced Eurocode 2 Part 3 and I've done my hydraulic gradient, I've identified what my hydraulic head is. I've spoken about what the crack width calculations are. I've liaised with the structural engineer. That sort of stuff we need to be doing. But I would strongly argue that this is now a bigger deal than it ever has been. And we need to start recording. I'm justifying how thick this concrete section is. I'm not just going for a big fat concrete section because it makes me feel better about how watertight that section will be. I just got a couple more slides and then we'll go on to the case studies. But I thought it'd be helpful to look at, this is the Riba plan of works. So Riba is the Royal Institute of British Architects, and they do this sort of flow chart of a design process. So you'd start here and somebody has a plot of land and they want planning. So they might think that they want a basement, but they start with appointing a design team. Most of the listeners here will be familiar with this issue. Whose scope is the waterproofing in? But stage 3 is where, certainly in my work, that's where we really start getting heavily involved. And we would be saying to the client, what's going in your basement? I'd never ask them how dry they want it. I'd say, what's going in your basement? What are the materials? What are the finishes? What do you want it to look like? And then I would tell them how dry they need it to be. So you'd start there, and then you would say, okay, we need type A and type B waterproofing protection, or type B and type C waterproofing protection, or just type B, or whatever it might be. But we need to be mindful of this. Can we reduce our embodied carbon? All of that sort of stuff. And to do that, we need a proper soil investigation, which goes back to here. If you can get involved there, then you can say, please give me a proper soil investigation. They've got time to do it. But the real design detail comes together in this, which is section Riba stage 4. And you might be looking at your hydraulic head, your maximum through crack widths, changing your pore sizes using different rebar designs. So rebar is the steel reinforcing. You might say, okay, we can't meet that, but we want to use a waterproofing additive. And then you've got to look after your value engineering issues, all of that stuff. Riba stage 5 is when the building actually gets built. So you want to be making sure that the contractor sticks with it and doesn't do bigger pore sizes or that sort of thing. That's a sort of flow chart, just to try and give you an insight into my mindset of, well, what am I thinking through? If I'm designing watertight concrete, how do I think it through? I'm just turning a page to check that I'm doing well for time. So, step 1, if I'm involved in a design that's got watertight concrete, I want to do my own hydraulic gradient assessment. And the reason for that is I think differently to the structural engineers and the civil engineers that I come across. I think a lot of the time, well, why would I not expect water to come to the full height of retained ground? Whereas I find a lot of structural engineers and civil engineers say, oh, okay, well, let's go off the borehole plus a safety factor, or let's go off the highest borehole reading, or let's go with 1 meter below ground level. Some of that kind of thinking is what they would use to determine the hydraulic gradient. I don't like that. I want to do my own. So once you've determined your hydraulic head, and your section thickness is normally very self-explanatory, you've got your hydraulic gradient, you can punch that into Eurocode 2 part 3 and say this is the maximum permissible crack width. Then you normally have some sort of issue trying to get a structural engineer to do some crack width calculations to say, actually, yeah, we are compliant, because it is a little bit arduous for them. And I think it's a little bit unfamiliar a lot of the time. So getting a structural engineer to do some crack width calculations is sometimes quite tricky. And then we need to be using some professional judgment saying, well, is that feasible? Is that viable? Because if you try and get your crack widths down very, very low, you can end up with so much rebar, there's not enough room for your concrete and you can get voids. And so you need to be using your professional judgment in that. And then you want to work collaboratively with the rest of the design team. Can you revisit borehole logs? Can you look at different section thicknesses? Can you change your pore size? Can you use different binders? All of that stuff's going on. But critically, you want to be justifying that you have done this work, and this is why you've come out with this answer. And I find your best friend in this is your latent defect insurer, because they have more clout than you often. So if you can say to the latent defect insurer, what crack widths are you anticipating that we need to meet, they would be quite helpful in getting your client on board. And then once you've sort of wrapped up your design, you want to make sure that everyone's on the same page, and particularly ensuring that the contractor is well informed so that pour sizes don't change and that sort of thing. So I think we're doing all right for time. We're now going to run through some case studies. And the first case study is from the north of England, and it's quite a deep basement used to house some heavy plant machinery. And so at Riba stage 3, the structural engineers had come up with this design. And I want you to notice this, that wall section thickness there is very thick. 1.1 meter thick reinforced concrete wall is unusually thick, and they were saying that the crack width should be limited to 0.3 millimeters. And they said use a waterproofing additive, and they mentioned external tanking, which would be a type A barrier. So that went off to tender. I think I probably just need to slow that down a little bit. So let me run through this again. Somebody's developing something that needs a deep basement for some heavy plant machinery, and they went to their early design development with a structural engineer and got to Riba stage 3, and this is the structural engineer's design, and it said crack widths up to 0.3 millimeters, waterproofing additive, external tanking. There's your Riba stage 3 design. That went off to tender, and the main contractor looked at it and said, we can build it better than that. We don't need to use so much concrete. Actually, we're going to use some sheet piles here. That's what these are, sheet piles. And that saves us a lot of time, which saves you money. You want to go for that. And then they ended up with this thinner liner wall, effectively. And that, they didn't really do any redesign on the rebar. So they didn't consider their crack width calculations. They also did some value engineering, got rid of this external tanking, and then they went off to tender and told the concrete contractor use a waterproofing additive, which is here somewhere. So the concrete contractor said, yeah, sure. And they got their mixed designs together, used a waterproofing additive, built it, and then it leaked. So we've got these leaks here. And you might notice that they are sort of parallel, they're mirrored. And the main contractor said to the concrete contractor, we're not paying you because it leaks. So you must have got your waterproof concrete wrong. The concrete contractor had to go to adjudication to try and get the main contractor to pay them. And we did some work with the concrete contractor saying, well, if you haven't done your rebar design, so as the main contractor who did the rebar design, which determines your crack width, and the concrete contractor simply put the mix together and poured it. Really, it's not fair to put that all on the concrete contractor. So you can't say whack a waterproofing additive in and that's watertight concrete. It's more complex than that. You have to consider your crack width calculations as well. That's case study 1. Case study 2, this is a performance specification I saw. So it's a very competent structural engineers team for quite a large scheme. And this is stage 4A. So that's very near to construction. It's a well-developed design. And that said, okay, according to BS 8102, we need a dry environment. Use a waterproof membrane here. Use water stops. And create water-resisting concrete, but without a water-resisting admixture. So that specification is going off to tender, and the main contractor is about to pick up design liability, and this is how they need to build this basement structure. Later on in the same performance specification, so again, grade 3 environment is what's required, and they stipulate this. So again, there's no waterproofing admixture, but the engineer is saying to the main contractor, achieve 0.2 millimeter crack widths for your water resisting concrete. and 0.3 for elsewhere. So this 0.3 is essentially, that's Eurocode 2 part 1, which is general structures, and this they're saying is sort of, well, it's Eurocode 2 part 3-ish. So if you look at the section detail, this is the section detail for that same development, and you've got a 300 millimeter thick reinforced concrete wall here. Just notice that you've got a canal just there, and this is your water table down here. So it's below the structure, so that might add comfort. So that might be why you'd say, okay, a 0.2 millimeter crack width and no additive. That makes sense according to the Eurocode. But just notice these datum levels. So ground level is about 60, and the bottom of the slab is about 55. So they said, okay, take your water table and add something to it, so some sort of margin for error, and take this, that's 57-ish, as your water level, and design your concrete to that. So they said design depth is 57 above ordnance datum. But from a waterproofing perspective, I'm thinking, well, what's the flood risk? Do we never think that there will be a full head of water exerted to that? So this is extracted from British Standard, and it's 6.1, says waterproofing measures should be designed on the basis of water to the full height of retrained ground at some time during the life of the building, apart from, and there might be some apart from. So I'm not saying this engineer's got it wrong, but I'm saying that there's this professional judgment where you might need to think about it differently. So if this is your 57, that's the designed level. Might it not be there? Should it not be that actually one day in the next 100 and whatever years, water will be up here, and that's going to exert a full head of pressure through here in this 300 millimeter thick concrete liner wall? Well, if you go to Eurocode 2 part 3 and you take this 57, that's what they took, you say that's the designed water level, and the bottom of the liner wall is at 55, your hydraulic head is 2 meters. 57 minus 55, 2. And your thickness of your liner wall is 300 millimeters. That gives you a hydraulic gradient of 6.6. And if you chuck that into your Eurocode 2 part 3, that tells you for class 1 watertight concrete, you have a 0.18 millimeter maximum permissible crack width. A little bit different to what they said, which is 0.2 millimeters. But what if you looked at it and you said, actually, we need to take ground level as the hydraulic head? Well, in that scenario, you end up with a hydraulic gradient of 20 and a maximum permissible crack width of 0.125. So there's some consideration to be done there. And what if you said, well, I am a responsible professional and I care about responsible use of natural resources. Do we really need a 300 millimeter thick concrete liner wall? Could we bring that in thinner? Maybe using a waterproofing additive would justify bringing that in thinner and not quite achieving the crack widths that you should achieve. That is worth consideration, I say. Case study 3, and this is a double-story basement car park in London, and it required grade 2 waterproofing performance. And this is a section detail that I showed you earlier. So I'm saying that ground level is up here, and the maximum hydraulic head could be up to 6.3 meters. Your liner wall thickness is 0.19 millimeters. Sorry, 0.19 meters, which is 190 millimeters. And that gives you a hydraulic gradient of this. That's a much thinner liner wall, isn't it? It's much thinner than 300 millimeters. But that gives us this sort of, we're at 33 hydraulic gradient, which gives us a maximum permissible crack width of 0.06 millimeters. So we're having to bring our crack width right down. And the structural engineers did some great work on that and worked very hard at pore sizes. And we used a waterproofing additive. And that meant that we were able to achieve watertight concrete with a much thinner section. And this is just a 3D thing that gives you an idea of scale, green being the watertight concrete. So on this sort of scale of project, if you can lose 100 mil off your concrete section, you use a lot less concrete. The embodied carbon for that building goes down significantly. But the way we had to do that was A, working very hard on the crack widths, and B, using a waterproofing additive, because we couldn't quite go as far down as 0.06 millimeter crack width. That is a bit of a whistle-top tour, and I imagine there are some questions which Andy will help me with.
Yes, no, there certainly has been plenty of questions, both via all channels. Folks, I'm just going to say to you right now, if you do have a question, best to fire it across to me as soon as possible. We do have quite a wee stack here building up. Ben, sorry, let me just kind of get into it. I have to say, your snake oil comment on the additives really kind of kicked up some comments and arguments out there, but from certainly my layman's point of view, it almost sounds like a catch-22 and a pass the buck loop. Oh, and just pass it on, someone else take responsibility for it.
Well, I think that's how a lot of waterproofing works, doesn't it? You get that a lot with all of the waterproofing, where architect designs it and says to a main contractor, you take design liability for that and build it, please, but it's too late to change the design. There's a lot of that goes on.
Well, anyway, right, kicking off questions. I think the first question from Jordan Daniels. What is the biggest cause of defect in waterproof concrete? Now, I know this is maybe a finger in the air because there's different kind of variables that might actually affect, but if you just limit to maybe your experience, Ben, do you know what have you seen as being the biggest cause?
Feels a little bit unfair to say, but probably workmanship. I think just realistically, you're having to prep day joints and things like that in amongst your rebar, and workmanship is the one that's very hard to get right, and there's massive pressure on site, and it's a dirty hole in the ground. Workmanship is quite challenging. I would say that's the biggest one.
You see, as a marketeer, some marketeers might actually take advantage of putting a training pun in there, but I won't do that. That was meant to be funny, by the way, but obviously it didn't come across that way.
I'm laughing.
Yeah. Well, anyway, next question. Next question actually from Patrick Flood. I believe you know Patrick. This one actually comes in via email. Patrick, there's actually several questions to this, but let me try and narrow it down just to kind of one point. But he's asking, what is the value of a performance guarantee with regards to water retardation? In addition, defect presentation with the use of admixtures when structural design service life exceeds its limiting value. Wow, that is quite a mouthful, Patrick. I hope you kind of got that, Ben, just from what I was saying there.
Well, you did kindly email it to me last night.
I wasn't going to say that.
It's still a difficult question to answer. So I think I'd summarize that as Patrick saying, well, what's the value? If you're saying that there's a guarantee that this structure is going to be watertight because your waterproofing additive guarantee is there, what's the value of that? Because that has an expiration date on it, and that expiration date is before the end of the building's life. And I think the same is true about pretty much anything. So your structural engineer is only really on the hook for 12 years after practical completion, but the building's life is obviously longer than 12 years. I think you would expect that if it was going to fail, it would probably do so in the first 10 years or 20 years, that sort of thing. So I still think there's merit in that. My bigger issue would be with your waterproofing admixtures. They're very limited in their value, and you've got to prove that it's the admixture that went wrong. And often that just comes down to commercials. If your waterproofing admixture supplier can just send a couple of guys out and do some resin injection, then they probably will. They're more likely to win work if they keep doing that. But if it comes down to a legal argument saying, well, it's your fault, you're the admixture supplier, it's very difficult to prove that the admixture wasn't appropriate.
Okay. Well, here, next question. You actually kind of semi-addressed this point during your chat, but it's been raised up in the conversation, but also I got a private message on it on my email as well. it's principally to do with thickness and watertightness. Does the thickness govern the watertightness, or is this not necessarily the case? If you can just give us a wee brief.
So no, not necessarily. There's these different things at play. So thickness will considerably impact the hydraulic gradient. But then what crack width you can have would be the determining factor. So if you've got a big fat crack, that won't crack heal. That won't autogenously crack heal. All the things that would block up that crack will carry on through. If you bring the crack down thinner, then that crack should block up. The longer that crack is, the more likely it is that it blocks up. I'm not sure if that clears it up at all, but I'll leave it there. Do give me a shout if you want to talk about it.
Yeah, and folks, if you've got a comment on this as well, I mean, feel free to use the chat. I mean, we're always listening, and we're always keen to chat too as well. Well, moving on now, I am going to say this. The next question is probably the most controversial question of the day, and also for the very first time is the first time I've actually had people commenting back to me via social media and sending me information that way. It's all to do with additives. So
wonderful.
Jamie, I'm a wee bit unsure how to pronounce your surname, Tischami, I think it is. He first raised it, and lots of people commented after it, which is, what are people's views on waterproof concrete on podiums? As a contractor, we certainly experience mixed messages from podium manufacturers. Now, I will say that David Bedford's, Liam, Paul Redford, Chris Mossert have all been kind of piling in on this. But what is your view?
So I wouldn't personally ever design a podium to be of watertight concrete. That's my own view. And I think there's several reasons for that. But here's a quick plug. Refer back to my previous webinar on podium deck waterproofing. But yeah, I think a podium deck, it's very similar to a roof. And you ought to be looking at designing a roof with falls and appropriate outlets and all of that kind of stuff. I think to design a podium deck of watertight concrete can be asking for trouble in terms of cracking, dynamic loads, thermal fluctuations, all of that kind of stuff comes into play. I've certainly looked at a few that haven't been successful.
Okay, all right. Well, moving on. Next question comes from Don Martin. Morning, Don. Ben, how can you ensure at build stage that a contractor does not change the pore size? Can this be checked after the pour, and where does the liability lie if it was changed?
Well, I think liability is quite straightforward. If your contractor doesn't build the design, then they built it wrong, and that liability is fairly straightforward. How do you keep? I think normally contractors wouldn't be looking to change pore sizes or not without permission. So what they would often do is they would ask, can we change the pore size to this? And because of commercial pressures, you might be inclined to say yes. And I guess what I'm trying to convey is don't say yes, or not without doing your crack width calculations as well. The alternative to all this is to bring the contractor in earlier and say, what pore sizes do you want to do? Because normally they're better at sequencing and understanding what pore sizes are going to work and how we're going to construct this building. You want to be liaising with your contractor closely and getting them on side and talking to them about what pore sizes work.
Okay. Yeah, I will say this, by the way, just folks on the chat, I can see your comments just on additives and podium decks and stuff. It's kicking up a bit of chat. Folks, I'm just going to say I will post up just Ben's webinar on avoiding failures in podium decks. I would encourage anyone that's interested, certainly just to kind of click on that link. I'll post it up in just a second. Ben, just to let you know, we're running really, really short on time. Guys, everyone on the webinar, probably going to run about a couple of minutes just over, but not too much. Ben, I'm going to fire you with 2 quick questions. If you can make them short, sharp answers, that would be much appreciated. But next one's from David's Beresford. Can crystalline systems wash out under high pressure before the crystals grow?
I'm sure they could hypothetically, but I wouldn't have thought so. I think because you're talking about such thin cracks, if you're talking about 0.1 millimeters, I wouldn't have thought so. And also, it's very unusual for crack to be straight. It would be more tortuous than that. So it's not a straight crack through the section. It goes around different aggregates and things like that. So I wouldn't have thought so. And I think you also often get sediment blocking it up and stuff like that. So I wouldn't have thought so, but welcome to be corrected if somebody else knows more than me.
Well, do you know, Paul Redford actually is kind of had a question just off the back of it. He's made us aware that there's now actually an admixture out there that has ability to both block pores as well as have the crystalline elements in there. But I suppose what he's asking is, have you used it, and what's your thoughts towards it if you have used it?
Yes. There's another newer one to the best of my knowledge, which would that uses a bentonite clay as well. And my initial gut reaction is skepticism, but I have to check that because of the whole sustainability thing. And I think sometimes we wear these challenging hats where we want to think about just how I want it to be watertight and I don't want it to go wrong. But we also must leave room for innovation, because if we just keep doing things the same way we've always done them, we're going to keep global warming on track. And I think it's very important that we allow ourselves to be challenged and we check our biases. I think something that's expansive, and there are many options out there, expansive things in cracks is bound to help, surely. My plea to the suppliers of such products is, please get us the right data. So if you're doing some sort of comparison, you've got your normal sample and your watertight concrete sample with your additive. You've got to make sure that those, when you get test results, they're comparable. And that's where a lot of the research is going, isn't as useful as it should be, I think.
Cool. Well, I'm going to call it a halt and question time just there. Folks, I've already spoken to Ben. He has mentioned questions that I've still got outstanding. He will get back to you. But just folks, if you're looking for some additional information, there are resources there. I would point you first of all to our best practice guide, and it's Type B waterproofing. The URL is on the screen there. But also there's a whole specialist professional document library that we are actually doing up at the moment in time. We have actually just been window dressing, updating, and etc. And we are doing more with the technical library. But the link again is there for you as well, which is just property-care.org/structural waterproofing documents. This webinar, of course, will be available to you also. But also, if you are in need of a knowledge boost, I just want to make you aware of some training courses that we do have. Now, unfortunately, all our severe courses are now fully booked for 2020. So if you are interested in a severe course, please do get in touch with us for 2021. But we do have limited availability on 3 of our upcoming structural waterproofing courses, that being a waterproofing awareness one, which is more your kind of basic level, waterproofing legal aspects, and also structural waterproofing update course. If you are interested, the contact number is there, and I know I've cut off the email, but if you contact our wonderful Jade at property-care.org, she will be able to help you out. Just to let folks know, our next webinar is a little bit different than what we normally do, but also very, very important. 25th of September, the risks of being an expert witness, being led by Paul Beckett. Now, at the moment, this is not quite up online just at the moment, but what I will do is, as soon as it's available for registration, I'll ping it out to all so you can register for the webinar. Last but not least, Ben, I just want to say a big, big thank you again for coming on board and for that presentation. As always, really informative. Got the chats going as well, controversial in some points also, which is always great because it gets the chats going as well. And I have to say, Fantastic as always. A big thanks always to our audience as well for joining us. Much appreciated. And I suppose it just leaves me to say, I hope you have a lovely rest of the day, no matter where you are, either in the UK or around the world. Many thanks, everyone, and goodbye from us.
Thank you all. Bye-bye.